recording. Okay.
So, hi, everyone. We are excited today to have two attendants with us participating with this journal group meeting. One is Dr. Suzanne Vernon, who is from the Bateman Horn Center. We're especially excited to have that connection with Bateman Horn Center, as it's one of our favorite resource places. And we appreciate so much the work that they do for people with MECFS and fibromyalgia and now long COVID. So Dr. Vernon, PhD, is the research director of the Bateman Horn Center and is one of the nation's leading researchers in MECFS. She completed an MS degree in microbiology from Colorado State University and a PhD degree in virology from the University of Wisconsin-Madison. Dr. Vernon has authored and co-authored 150 scientific papers and dedicated the past 20 years of her professional research career on identifying biomarkers and causes of MECFS. She completed her postdoc research at the U.S. Centers for Disease Control and spent 17 years studying human papillomavirus and opportunistic infections and complications in people with HIV, and implementing state-of-the-art techniques to discover novel pathogens in population-based samples. Early in her career, she observed that HIV-infected women have higher rates of cervical cancer and published one of the first papers to show that one of the HIV proteins could activate human papillomavirus to turn on its cancer-causing genes. Dr. Vernon co-authored a landmark paper that determined that severity of acute infection rather than the type of pathogen was the strongest predictor for developing chronic sequelae and disability. She co-authored and papered in Science on a technique called VirScan that tests for antibodies to over 200 viruses in a drop of blood. And our next guest, Dr. Shad Roundy, PhD, is an associate professor in the Department of Mechanical Engineering and is an adjunct associate professor in the Department of Electrical and Computer Engineering at the University of Utah. He's the director of Integrated Self-Powered Sensing Lab at the University of Utah, which focuses on energy harvesting, wireless power transfer, and more generally applications of ubiquitous wireless sensing. He received his PhD in mechanical engineering from the University of California, Berkeley in 2003. And from there, he moved to the Australian National University, where he was a senior lecturer in the systems engineering department. He spent the next several years with several startups, developing micro electromechanical system pressure sensors, accelerometers, gyroscopes, and energy harvesting devices. He joined University of Utah's Mechanical Engineering Department in 2012. So a very interesting team, biology and engineering, talking to us today. So fascinating.
So Sally, do you want me to start or yeah, so Shad and I have it so that I'll make a little introduction to what we're going to be talking about, uptime today, what Shad will be talking about. So let me share my screen and put this in presentation mode maybe. Is that not working? Why is that not working? There we go. So thanks so much, Sally, for that invitation and for the invitation to talk to this group today. We're pretty excited about it. I want to give a little bit of background on how Shad and I met and started this collaboration, which is a really novel collaboration, as you can tell from our backgrounds, and also a really exciting one. So at the Bateman Horne Center, one of the things that the research department does that I head up is try to develop objective ways of measuring, assessing MECFS. And this takes the burden away from patients, answering questionnaires, and it also improves efficiencies with how, hopefully will improve efficiencies with how clinicians can do the diagnosis and assessment of MECFS. So many of you may be aware of this criteria here. This is the criteria that was put together by the Institute of Medicine, a committee that Dr. Bateman at the Bateman Horne Center was a member of this committee that put it together. And part of the criteria is this impaired function, this substantial decrease in function. And if you have that, that is one of the required criteria in order to eventually get a diagnosis of MECFS. And so when I came to the Bateman Horne Center in 2015 on a full-time basis, what I saw was, let's see, go to the next slide, that one of the tools that Dr. Bateman used in diagnosing MECFS was this thing called hours of upright activity. And I quickly learned that the providers at the Bateman Horne Center found it to be one of the best clinical tools to assess impaired function, that required criteria for MECFS diagnosis. So what hours of upright activity, or HUA, is the number of hours spent with feet on the floor in 24 hours. And this includes sitting, standing, walking, anytime your feet are on the floor. And again, Dr. Bateman and our providers knew that the more time with feet on the floor, the more function a patient had, the less HUA, the more severely impaired the individual was. This is the kind of tool that they used in order to be able to elicit that kind of information from a patient. They showed a little picture of how many hours do you spend upright, again, standing, walking, running, sitting with feet on the floor, reclining or sitting with feet elevated, and lying down, which includes sleeping. And again, what patients would do would be to come up with this formula over the 24-hour period. And as you may be aware, patients are really good at reporting this, but one of the things that we wanted to do in our research program, again, to be able to assess this type of information objectively and passively and remove the burden of this self-report from the patients, was to ultimately develop a way to objectively measure HUA. And that's what Shad will be talking about. So typically HUA for a normal healthy adult, the hours of upright activity that a normal healthy adult has is between 14 and 17 hours a day. Again, that includes feet on the floor. Chronic illnesses, including fibromyalgia, and this is data from the Bateman Horne Center. It's usually around 10 to 12 hours of upright activity. And patients with MECFS usually have 0 to 7 hours of upright activity. The upper end of that, 5 to 7, are patients with more moderate function. This is just an example of how hours of upright activity correlates with orthostatic intolerance. Okay, and this is a particular measurement that correlates orthostatic intolerance with daily activities. The daily activities that we're looking at are standing a short time, standing a long time, walking a short time, and walking a long time. These are again, measurements from this particular questionnaire. The blue bars are people that are healthy adults. The green are hours of upright activity in patients that have greater than 8 hours of upright activity. The yellow is between 5 to 7. The orange is between 3 to 4, and the red is between 1 to 2. And as you can see, the red and the orange are the more severely affected patients. And the more severely affected patients have much more interference with these normal daily activities, depending if they have less hours of upright activity. And all of these differences are significantly different from a healthy individual. So this is giving us an indication of the effect of orthostatic intolerance on a patient's ability to be upright and to be able to function daily. We also know that hours of upright activity has an effect on the symptoms of orthostatic intolerance. Same color scheme here, with the red and the orange being the more severely affected MECFS patients with the least amount of hours of upright activity. And we have significantly more symptoms: head and neck discomfort, trouble concentrating, fatigue, weakness, problems with vision, dizziness, etc. So again, the fewer hours of upright activity, the increased symptoms associated with orthostatic intolerance. And finally, we also know that hours of upright activity is significantly associated with being unemployed or on disability. And this is shown here. Here are MECFS patients that are employed, and they have an average hours of upright activity of about 8 to 9 hours of upright activity. And then MECFS patients who are unemployed and on disability have an average hours of upright activity of 5, and this is significantly different. So I think that's all I wanted to talk about. Again, for the reason that Dr. Bateman and I ultimately reached out to Shad to help us figure out a way to objectively assess hours of upright activity, objectively and ultimately passively, so that we could use this Hua as a way to not only assess disease severity in the clinic, but ultimately to be able to have a measure, potentially a biomarker that we could use in clinical trials. We could use hours of upright activity, or what you will now know as uptime, as an outcome measure in clinical trials and other clinical research. So yeah, we were connected to Shad by an investigator in the UK who turned out to be who I reached out to, and I said, would you be interested in working with us to help us understand how to develop a device? And he said, well, I actually have a good colleague that's right next to you who would be even better at this than me. So he made the introduction. I can't remember this guy's name in the UK.
Eric Yateman is his name. Yeah.
Yes. And so Eric made the introduction, and Cindy and I went and met Shad. Now it was back in 2018, and we've been working together ever since. So let me stop sharing.
All right. And I'll take over and share from here. So there we go. So yeah, thanks for that. So this has been a pleasure the last few years to be able to work with the Bateman Horn Center. Thanks for the invitation and for the nice introduction, Sally. So I have to say, this is kind of fun for me. We're widget builders, so I've spent a lot of time, building little doodads, technological doodads, usually having to do with capturing energy or sensing. But it's fun to be able to use them to do something that's actually useful in the world. So this is it's been educational and a lot of fun for me. As I told Suzanne, I had a good friend when I was younger who had MECFS and had just a little bit of firsthand experience, secondhand experience. Then I haven't really kept in touch, but it's nice to sort of get linked in here and work on something, like I said, that actually makes a difference in the world. So I'm an engineer, and here's my lab. And thanks, Suzanne, for giving the sort of clinical introduction, which I can't do very well. But we build small things. Here's two different versions of students in my lab. And the reason I'm showing these are to highlight a few people who did a lot of the work here. So this guy here is Turner Palombo holding his beautiful baby. And Turner is now at Sandia National Labs. And this guy here is Bin Duc Truong. Bin is now at the University of Michigan. And they did mostly Turner, honestly, but Bin and Turner both worked on this. And then Bin's wife, Thuy, wasn't in the picture on the left. I put the picture on the right. Circled here on the right is Thuy, who's technically not a member of our lab, but she's an honorary member of our lab and a superb mathematician. And I happen to know helped out on a fair amount of the data analysis here. So with that, so Suzanne already introduced Hua, right? I don't need to go back through that. Some of the weaknesses are it's not seen as objective sometimes. It's a little bit low resolution, meaning that people can't report this down to the level of minutes, for example. And it's not passive. It requires people to actually constantly be thinking about it and reporting it. So the sort of the big question or the challenge, I guess, that Suzanne and Cindy gave us was, can we measure Hua in a way that is passive, accurate, objective, and continuous? So, I mean, the short answer is yes. And we call this measurement uptime to distinguish it from Hua. Uptime is measured passively with a sensor, as opposed to Hua, which is from a self-report questionnaire. And what I'm going to do is go through how we measure and calculate Hua. Actually, I've got an outline here. Yeah, how we measure and calculate uptime, rather, not Hua. And talk a little bit about an initial study in which we used uptime to distinguish between levels of disease severity, a little bit of extra data analysis following up from that study, and then our plans going forward. So the key to the way we measure this is what's called a 6-axis inertial measurement unit, which goes by IMU for short. And an IMU is simply it's 6 sensors, 3 accelerometers that measure linear acceleration along 3 axes. So in this picture, we're measuring the linear motion in the X, Y, and Z directions. And then it's 3 gyroscopes. And gyroscopes measure rotation rate. So in aerospace parlance, these rotations are called pitch, yaw, and roll. But they're just simply the angular rotation about the 3 axes. And the sensors actually measure rotation rate, degrees per second, not degrees directly. But these IMUs have been used for a long time in the aerospace industry, fancy, expensive IMUs. And this is how, like, autopilot in planes self-stabilizes and knows what orientation the craft is in. Drones, for example, or even like little quadcopters use these to partly to navigate, but mostly to stabilize themselves and know which orientation they're in. So they've been used historically for a long time. Now, more recently, There are low-cost IMUs now, which are not as accurate, but incredibly inexpensive, and they're literally in everything. Pretty much every wearable now that you buy has at least one IMU in it. Your phone has multiple IMUs in it. They're used for virtual reality goggles. There's billions of these sold every year. I spent about 4 years of my life, let me think about that, 3 years of my life, developing a 6-axis IMU with a company called Fairchild Semiconductor. That's this one down here on the bottom. So that picture on the bottom is just a picture of the piece of silicon. That's a gyroscope. Not that that really means anything, but that was before I came back. So I spent a couple years teaching in Australia, and then I spent about 8 years working in semiconductor companies, and then I've been at the University of Utah since 2012. So in my previous life, working in companies, I did a lot of work with IMUs. Now they're just commodity products, and they're just sort of in everything. So that's what we're going to use, or did use rather, to measure uptime. The one we used is called Shimmer, but there's lots of these research IMUs that you can buy that can either stream or log data. We like this because for example, in your you don't have as low level access to the IMU data in a lot of wearables as you do in these. We can control things like the sample rate and the range of measures and all sorts of things like that. So this is what we use, and what we do is then we just place this on actually 2 of them, one on each lower leg, so somewhere around the ankle. And then the IMU, from the IMU, we can calculate orientation. So the IMU knows which direction is up. Really what it's measuring is the direction of gravity. So it knows what its own orientation is with respect to gravity. And then we conceptually just sort of create this cone, so which has a critical angle, which we call, well, it's theta sub c. We're using 39 degrees. I'll get to later why we chose that. But so we have this cone, and as long as your lower leg is inside the cone, we determine that upright. So the first question we had is, how do we know that the IMU is accurate? They have some lower level issues which can make the orientation calculation not particularly accurate. So we ran an initial study to just determine the accuracy of calculating uptime with an IMU. So the way that we did that is we had a few subjects go through a choreographed set of positions, right? So they would sit with their lower legs vertical, sit reclined at different angles, sit with their lower legs horizontal, on a stool, walking, etc. We had them go through these 8 positions. And then what we did is we put them in a motion capture studio. So this is one of our motion capture studios at the University of Utah. You can see here there's all these cameras. So this is an optical motion capture with cameras. There are, I think you can see 1, 2, 3, 4, 5, 6. There are actually 9 going all the way around. And then we have the person do these motions inside the motion capture studio while wearing the IMUs on their lower leg. And I didn't have a picture of the actual subjects doing this in our motion capture studio, so I just grabbed another random picture so you can see sort of what it looks like. We put these little white reflective markers all over the person, and then the system will create a 3-dimensional kind of stick figure image, and then we get the orientation of the lower legs from the stick figure image, and we determine that as our ground truth. So the motion capture with the cameras is very, very accurate. And then we also calculate the orientation of the lower leg from the IMU, and then we compare the two. So we're using the optical motion capture as the ground truth. If you're not familiar with this, these are the exact systems that the movie industry uses to create realistic motions in like 3D animated movies and so forth. So to get like Gollum's motion, for example, and you can see all the little reflective markers on the guy here on the right. So, so we've got this data from people in the optical motion capture as well as with the IMU on their leg. And the question first of all, we just determine how accurate are we at getting that angle. I don't show the graphs here, but we are within a couple of degrees of accuracy with the IMU, so we're happy with that. And then the second question is, how do we determine what this critical angle is? And we use 39 degrees. There's nothing really magic about that. We had really two criteria for selecting that angle. One is that it should be something that makes intuitive sense. So you probably want something between, 25 or 30 degrees and 45 or 50 degrees to make intuitive sense. But then what we did is we took a whole bunch of subjects and we calculated uptime as a function of that critical angle. So this is just 3 graphs here. And the horizontal axis here is the angle, the critical angle in degrees, and the vertical axis is uptime. And what we're looking for is a range in this graph that, again, makes sort of intuitive sense in the neighborhood of 40 degrees or so, but also in which the lines are flat, pretty flat. So what we would like is, we would like the uptime number to not be very sensitive to the critical angle. So in this flat region, we could select a critical angle of, let's say, 45 or 50 degrees if you look at this top, and our uptime calculation would almost not change at all. So that's what we're looking for, is a range where the uptime calculation is not very sensitive to the angle. And we end up with 39 degrees. 39 degrees doesn't look obvious from these 3 graphs here, but we have a bunch more data, and we actually, the angle at which the uptime calculation is least sensitive is 39 degrees. But again, it doesn't matter that much, right? So if you choose 38 degrees, 42 degrees, anything in that range, you should get an answer, an uptime number that is similar. And then what we do is we calculate uptime from the motion capture system using that critical angle and from the IMU, and see how different those two numbers are. We don't have a lot of data here, but something, we're below about 3% accuracy using the IMUs. So we deem that accurate enough, right? So we are confident that we're getting an accurate enough measurement using the IMU that we can go ahead and use that in a study. So the next step that we did then was to conduct this pilot study with 15 subjects. And the goal of the pilot study was really, one, to see if we can distinguish disease severity, MECFS severity, using uptime. 2, to see if we can detect a change in physical function using uptime. So what we did is we had study participants undergo what's called the Nasoline test, which is just having them stand upright for 10 minutes, leaning slightly against a wall. The idea behind that is to induce post-exertional malaise, and it's not a very vigorous challenge, but the idea is to induce post-exertional malaise and see whether we can detect that change with the sensor with uptime. The idea being that if we can do that, then we can probably detect changes in uptime going the other direction from treatments, for example. And then the last goal is to see how well uptime correlates with hours of upright activity, Hua. So what we did is, again, we just had 15 subjects. This is a pilot study. We had 5 healthy controls, 5 people who had moderate CFS, and 5 with severe MECFS. And the subjects wore 2 IMUs, 1 on each ankle, for 6 days. So we had them just wear it for 3 days to gather a baseline. Then they came back into the clinic and performed the 10-minute Nasoline test, and then went back home and wore the same system for 3 more days. So we have 6 full days worth of data on 15 subjects. This is just a picture of how so they wore it 24/7 in the shower, everything. So this is just a picture of the IMU device and it being packaged up with some Tegaderm tape to keep it waterproof and wrapped around the lower leg. This is all a little bit obtrusive going forward. So in our next study, we're going to have something that just looks more like a band that you can just wear around your ankle like a watch band. But this is how they looked for this study. We also had participants wear an Oura Ring. So this was just sort of to gather some extra data. Suzanne had some Oura Rings. If you're not familiar with this, it's really a fantastic wearable. It measures lots of things. It measures, it has an IMU in it as well. So it measures motion of your hand. It measures heart rate. And from that can get heart rate variability, and they have proprietary internal algorithms from which they calculate things like a sleep score and a readiness score and some higher level parameters like that. So we'll come back to this later. Focus on the IMUs and uptime initially. So the first thing we wanted to do was to compare different disease groups. So that is healthy controls versus moderate versus severe MECFS. So let me just explain what this is. We got 3 groups, 5 healthy controls, 5 moderate, 5 severe, and we have 6 days, day 1, day 2, day 3, day 4, day 5, day 6. For each day, we calculate a percent. So uptime, we're reporting this as percent of the day, not hours of the day, but this is the percentage of the day that the person spent upright. And you know, the higher the number, the more green the cell is, and the lower the number, the more red the cell is. So you can see that the controls are largely green with large numbers, 40%, 30%. So, you know, 33% would be 8 hours. Yeah, 33% would be 8 hours. The moderate group, a little bit more mixed. The severe group, mostly red. So just qualitatively, it looks like there's a pretty significant difference in our measured uptime for the different groups. We can do this a little bit more quantitatively by plotting for each group 95% confidence intervals, right? So we have on the left is the control group, and then this is just the whisker plot here with the tails showing the 95% confidence interval for uptime percentage for each group. And it's pretty clear here that the confidence intervals do not overlap, that we have a significant difference between the 3 groups measured by uptime. So we did a few different tests. We did an analysis of variance and Tukey's test between the groups to distinguish between, you know, moderate versus control, severe versus control, et cetera. What we find is that the uptime percentage is significantly different between the 3 groups. And we can sort of build this, it's quite preliminary, but we can sort of build this scale here from the data, which would indicate we would classify people below 20% as severe, the severe group, the moderate group between 20 and 30%, and then the healthy group above 30%. So again, this is sort of preliminary. It's not a large data set, but we can sort of build this scale here now with, you know, 0 to 20 severe, 20 to 30 moderate, and above 30 healthy, which maps roughly to the Hua scale. So good. That's the first thing. Can we distinguish between different groups with uptime? The second is, can we distinguish before versus after the Nasoline test with uptime? So the idea here is, in time, temporally, can we distinguish a change in physical function? And the answer there was no. So if you look at these graphs, we have 3 different groups: control, moderate, and severe. On the left is the baseline. So that's the first 3 days. That's the average uptime for the first 3 days. And then 1, 2, 3 here is day 1, day 2, and day 3 after the Nasoline test. And first of all, what you'll notice is the confidence intervals all overlap, right? There's no significant difference between the baseline and any of the 3 days after the Nasoline test. I mean, we do note that oddly in the control group, there's a little bit of a fall off, but that's not a significant difference. So I don't think we can read anything into that. And we think really here what happened again. So we did all the tests, nothing is significant. We have a small sample size, so that's one issue. But we think that there's a couple of problems here. One is that the Nasoline test is just not that aggressive a test and probably not severe enough to induce post-exertional malaise. The second is that the subjects were taking medication, we didn't control whether they were or were not taking medication. So there is some sort of compensatory effect perhaps from that. And we just think that we didn't actually induce much of a change in physical function there. So that bit, we didn't really learn much from that bit of the study. The last thing we want to do now with this study is compare uptime to Hua. And let's talk about the graph on the left first. So this is every subject day. So each bar or on the left here is one subject day. So there are 90 total of them, 15 subjects over 6 days. And the gray bars are their self-reported hours of upright activity converted into a percentage of the day. And the red bars are uptime. So the first thing you'll notice is kind of what we already saw, that both with Hua and uptime, you get a pretty clear difference between control group versus the moderate group versus the severe group, with the uptime percentages being quite lower with the severe group. Now, the right graph actually correlates the self-reported Hua with uptime for each person day. And we've color-coded this by group. So the blue is the control group, the gray is the moderate group, and the red is the severe group. What you'll notice with the blue group is that there's a nice correlation. In other words, people who self-report more uptime also get measured, self-report more Hua, more hours of upright activity, also have higher measured uptime. That's what we would expect to see. Oddly, though, that doesn't seem to be the case so much with the moderate and the severe group. And in fact, if we take uptime as the objective measure, we find that both groups significantly over-report their hours of uprightness. Now, I mean, you can question whether uptime really is the standard here or objective or not. But at any case, the Hua is larger for some subjects than uptime. So another way to say that is that the measured uptime is more consistent within a group than Hua. So if you look at the red dots, we measure kind of all between 0 and 20 for the most part, but the self-report goes from 0 all the way up to 50. So the measured values are more consistent than the self-report values here. That's maybe the other takeaway there. So the last question we asked here was, do we really need an IMU on each leg? So we can calculate uptime using both IMUs. And what we do is we just separately calculate it with each leg, and then we take an average. Or we could just calculate it with the left leg, or we could just calculate it with the right leg. And for this group, what we found is there's no significant difference between doing right versus left versus both. That's useful because going forward, it's easier to wear one IMU on one ankle than it is to wear two IMUs on two ankles. And it looks like to us that we get the same answer regardless. So the conclusions from this study, which I would label promising conclusions, are that we can calculate uptime using a single IMU, and that the different groups, control, moderate, severe, has significantly different uptime, and we can generate a preliminary scale from that. The not so promising conclusions, or things that we need to look into a little bit more, is detecting changes in physical function with uptime. So we haven't demonstrated that yet. And then better understanding what I would call this strange correlation between uptime and Hua. So that's the results of the pilot study we did with this. And I put up a thing to the paper here. So we've published this in the Journal of Translational Medicine. So that although this presentation probably gives a little bit more detail than the data in the journal article, that is available in the journal article as well. But we actually had a much more rich data set. So, I mean, the publication of that journal article and the conclusion of that study sort of corresponded with Turner graduating and moving on to Sandia National Labs. So, but we have a lot of data, a much more rich data set. So we did a little follow-on study, which is frankly still ongoing a little bit, but we can get a little bit more detail from this follow-on study. So I'll briefly go over some of the things we did. First of all, other studies have shown a correlation between steps per day and MECFS. So for example, if you wear a lot of wearables, your watch, Fitbit, whatever, they'll calculate it. They'll give you a number, a steps per day number. And we can calculate steps per day from the IMUs on the ankles. Actually, it turns out you can get much more accurate steps per day calculations from your ankle than from your hand or your arm, which is not terribly surprising. So we can get pretty accurate steps per day counts from those IMUs. We've also not made great use of the Oura Ring data, so we're going to look at what we can determine from the Oura Ring data as well. So in particular, looking at the Oura Ring, this is a little bit of a cluttered slide. I should clean that up. We can get a lot of stuff from the Oura Ring. We specifically looked at these outputs from the Oura Ring. They report a lowest resting heart rate over a 24-hour period. They report the number of sleep hours. They have a score that they give you, a sleep score, what they give you called a readiness score, an activity score, how active you are, an average heart rate variability, and awake time. So how much time you're awake. And I actually haven't dug into the numbers that well to see if sleep hours plus awake time equals 24 hours or if there's some intermediate between those two. But and then we also used steps per day. So we did paired t-tests for each of the individual predictor variables. We also did a logistic regression model to find the best logistic regression model to predict disease severity using all of these data. We have 15 subjects over 6 days, which comes to 90 total measurements, but there is some missing data. And so we end up with 66 total measurements. And here's just kind of a quick takeaway. We find that both uptime and steps per day give us significant differences between groups. That's control, moderate, and severe. We find that lowest resting heart rate, sleep hours, readiness score, and average heart rate variability all give us significant differences between at least two of the groups. But I call those ambiguous, and I'll show you why I think those are ambiguous. And then sleep score, activity score, and awake time were not significant. They did not give a significant difference between the different groups. So let's look at uptime and steps per day quickly. This is plotted with different software, but this is the same graph I showed you earlier where you have 3 different groups and 95% confidence intervals for each group, control, moderate, and severe. You see the confidence intervals do not overlap. That makes them significant. And there's a monotonic trend. So it's going, so control's highest, moderate's in the middle, severe is lowest, right? So a line going down. It actually looks surprisingly linear too. So that's the kind of pattern we'd expect for a significant parameter. If we look at steps per day, we see almost exactly the same trend. We see non-overlapping confidence intervals. We see high steps per day for controls, medium for moderates, low for severe. So that's good in the sense that we can get perhaps the same or similar information with steps per day. The reason that that's potentially useful is there are so many wearables out there that already report steps per day. Now, I will caution that if you wear like the Oura Ring or a wrist wearable, that steps per day calculation is not as accurate as we get from the ankle. So I don't know how well that correlates, but anyway, this is a useful outcome. Well, I'll also note that steps per day and uptime. So on this graph, you have uptime on the vertical axis and steps per day on the horizontal axis, and we've color-coded the regression lines here. And so they're pretty well correlated with each other. So that's not terribly surprising that more uptime also means higher steps per day. The correlation coefficients are, between 0.35 and 0.75. So pretty good, not perfect, but pretty good correlation coefficients. And so we're getting some perhaps redundant information between uptime and steps per day. Now, if we look at, so that's all significant and unambiguous. This is what I mean by significant but ambiguous. So this is lowest resting heart rate. And you'll notice we got the control group, then it goes down for the moderate group, but then up for the severe group. And there's not actually a significant difference between control and severe, but there is a significant difference between moderate and severe. So I don't really know what to make of that. I mean, statistically, there is a significant difference between moderate and severe, but it's not clear what's going on or what that actually means. You have a similar story with sleep hours, and you have a similar story with the readiness score. So again, control actually has the lowest and then highest for moderate and then somewhere in the middle for severe. So, and we did a bunch of logistic regression models with these two, which I won't go into the detail of those. But I think the takeaway here is that we can't, from these higher level Oura Ring parameters, we don't really have a story to tell. We don't have something that seems to provide meaning at this point. But we clearly do have a story to tell with uptime and steps per day. Oh, here's average heart rate variability, similar kind of ambiguous result. So none of the Oura Ring parameters seem to tell a clear, unambiguous story. I'm going to jump over the details of the logistic regression stuff here. It's a little bit in the weeds and a little detailed, but it doesn't really add much to the overall story. So I'll jump over that quickly and say that it doesn't seem that the Oura Ring parameters at this point are giving us a lot of extra predictive capability. However, I will say we can dig into the lower level data with the Oura Ring, which we have these lower level data sets that need to be time synchronized, and we may actually still end up getting some interesting outcome from the Oura Ring. So let me just summarize here what I think the study conclusions are. One is that uptime is a significant predictor of MECFS disease severity. Two is that we can calculate it with a single IMU worn on the ankle, so pretty unobtrusive. Steps per day is also a significant predictor. And we don't know whether we get better predictive capability yet if we use both measures versus just one or the other, but it's possible we can even get better predictive capability using both measures. The Nasoline test does not seem to have precipitated post-exertional malaise, so we need to follow up there. And the higher level parameters from the Oura Ring don't seem to make much of a difference. So with that as our, current state of knowledge, here's our plan going forward. We currently have some funding and plans to do a follow-on, more comprehensive study. We're going to use 75 subjects over a 14-day period. I believe that's still correct, although we're still finalizing the study design a little bit. We will measure uptime, steps per day, Hua questionnaire once per day, and also the physical activity subscale of the SF36 questionnaire, which has also been shown to correlate with MECFS disease severity. We'll just use one less intrusive IMU on one leg. So doing this for a longer period of time gives us a longer baseline. We have a larger number of subjects that we should be able to get a more refined, a better confirmation of our conclusions. And then the goal really is to prepare this and submit a biomarker qualification package to the FDA so that uptime could be used as an outcome measure for treatments for MECFS. With that, I'll just again acknowledge the students, Turner and Bin, who both graduated, so they're no longer students, but they were students when they did this, who did most of this great work. And Thanks to Suzanne again and the Bateman Horn Center for this great collaboration. We've also received funding here from the Solve MECFS Foundation or initiative, and also the Utah NASA Space Grant Consortium. And so with that, I guess I will conclude, and thank you again for your time. And I know that people will be watching this. I'll just stop my share here. I know people will be watching this on via the recording. So, if you have questions or interest, you can, I'm not too hard to find. You can feel free to contact me. Thank you.
That was awesome.
Yes. You.
Yeah, fascinating. Look into, I appreciate the depth, because looking at both of the studies, studies just kind of give a that cursory overview, and to be able to see the behind the scenes was really, really fascinating. So I had a couple that I was wondering about. I can't remember, honestly. I'm in a real fog state right now. When you guys selected the candidates for the study, what were your criteria for identifying them?
Yeah, you probably don't remember it because I didn't state it.
Okay.
But Suzanne's actually probably the better person to answer that question.
Yeah, so we selected the severe group based on less than 5 hours of upright activity, and the moderate group was between 5 and 7 hours.
Okay.
So
Yeah,
so we have historical data on these folks, and that's how we selected.
Okay. And when you did that, were you using Dr. Bateman's, these were drawn from patients who had been diagnosed using the case definitions of IOM or previous definitions, or are you aware of what the definitions were at the time?
Yeah, so we use these particular people are patients as well as research participants, and they all satisfy IOM criteria, Canadian, and Fukuda.
Okay. There's one of the challenges that we're having actually in our in trying to work with clinicians is really trying to work with it to educate about the historical misuse of research in MECFS, and how so much research was done using, chronic fatigue diet, symptomology, and then not clearly stating that what that was, and then clinicians basing decisions based on not really understanding the research. And so that's one of the questions that we ask almost everybody to clarify, so that we can make that case that no, these were done so that we know that they met these criteria, and this is not your generic pool of persons that might be burned out or tired of.
Yeah, it's such an important point. And, that kind of rigor in applying the case definitions to research participants is I think, also one of the most important aspects of research, and has not been done very rigorously.
Yeah.
For a number of reasons, because a lot of people aren't familiar with the various case definitions and how they should be operationalized in their patient population in order to make them qualify for research. So that's one of the really important things that we focus on at Bateman Horn Center. Again, trying to do clinical research that uses exquisitely characterized, clinically characterized patients that are defined by the accepted criteria, so that when we put them into various research studies and biomarker studies, that we're pretty confident of, we're much more confident of the answer.
Right, what you're looking at.
Exactly.
Yeah. And I think for healthcare providers, then it goes one step further. All this recent work that everybody's doing on trying to get the ICD codes cleaned up, so, the idea that people with chronic fatigue were being put into studies with people who have MECFS, or according to World Health Organization, ME, they're not the same, and so for a clinician to understand all these weird political things that go on in healthcare, and how they actually play out in how you read the literature, makes a big difference, I think. So thanks.
Yeah, and again, I think it's so important, and why we are really aiming to objectify the various measurements. Since we don't have a blood test or a series of blood tests, can we use the case definition criteria, the IOM criteria, for example, create objective measures for those, and then ultimately create the kind of scales that Shad showed that puts you in a certain category objectively.
Yeah. What about Melinda? I don't want to hog the questions, but what about so again, this is based on a lot of back and forth with PTOT clinicians. To me, this stuff that you guys have presented is just so clear cut and obvious, and I mean, it makes so much sense, especially the way you guys have presented it. But when you have clinicians who question the validity of the illness from ground one, have you run into pushback that the uptime or the Hua is a result of a psychosocial component anyway? Okay, so we can objectively categorize these into mild, moderate, and severe, but that the causative agent is still a psychosocial trigger.
We have not.
Okay, that's good.
Yeah. We have not. I mean, it is important to ultimately, when we submit the biomarker package, we will have to show the sensitivity and specificity of it for MECFS and other diseases. Other diseases where there is a lot of impairment that is not due to, or that is due to mental illness, for example, depression, where there isn't the motivation to be upright, for example. That kind of differentiation is important, and that's something that Dr. Bateman has talked to us about quite a bit. And I'm not a clinician, so I won't go down that route, but we are aware of the need to be able to demonstrate these types of properties for any kind of biomarker and objective measure.
Yeah, because my next, I can see in the next 6 weeks a conversation around this presentation being had with someone that says, well, of course their Hua, their uptime is going to be low because they are depressed, or because they are, well, if they would just get up,
Right. So we do measure various, we use the HADS, and the SF36 has some of the subscales in it to look at, and it just doesn't fit, most of the majority of our CFS patients are in the normal range for emotional and psychological properties, and it just doesn't fit. So we can defend that.
Right.
Yeah, and Suzanne, correct me if I'm wrong, because I always feel a little uncomfortable when I start making statements that are so far outside of my domain knowledge. But I think that, the real utility here, as I understand, is probably not so much in diagnosing people in the first place, right? There are we have case definitions to diagnose people. It's to evaluate the effectiveness of a treatment, right? So you have someone who's already diagnosed with MECFS. So you don't, then the question just becomes is, how do you measure whether a treatment works and how well it works?
Right. Yeah, and I think that's what makes, for sure, it's just that the power of the biopsychosocial forces in physical therapy and occupational therapy are so strong currently that this is the resistance that we would run up. I mean, I'm already anticipating the conversations that will be had about this. So and then so the availability of the shimmer is for clinicians is basically waiting for that next study in the FDA type approval.
Yeah, so we shouldn't get fixated on the shimmer device specifically. That's one example, but you could do the exact same thing. Our next study, we're going to use a different device for several reasons. But there's lots of devices that have an IMU in it. So I don't know, Suzanne, I'm sort of guessing a little here, but the way I envision this is we might be able to say, okay, here's a set of devices you can use, right? Here are the procedures on collecting the data from these devices. And here's a set of, here's a piece of software that will take you from the raw data to uptime. And then a clinician could use whichever device they want. It wouldn't really matter. And there's lots and lots of them out there as long as they can shove the data into our piece of software.
Yeah, well, that'd be great.
Yeah, it's more the algorithm behind the app, ultimately, the Uptime app that we haven't developed yet, but that's basically, hopefully we'll be able to do exactly what Shad just said.
Okay, that sounds awesome, because that's the other thing that clinicians are constantly sharing with us is it's although we feel strongly that there are many that think that they understand ME, the biology of ME maybe more than they think they do, but they want tools. They want the tools, and so we keep saying, go back to the basics, make sure you understand PEM, make sure you understand pacing, and then apply your tools that you already know, but they want the tools associated with it. So that will be a powerful piece to offer them at some point. That's one. That's all I had. Thank you so much for answering those questions. Oh, any last question was any other thoughts on, since the NASA didn't elicit the PEM like you were hoping, any other thoughts on a PEM trigger that might be tested?
Well, in our most recent grant application, we proposed an exercise challenge, but I think that the reason the Nasoline test didn't induce a change in upright activity is because that we didn't require patients to be off of their meds, and most of the patients, all of our patients are very well managed. Yeah. So that's what we think is really the reason behind that lack of detection of change.
Yeah. Makes sense.
Because, we do the Nasoline test on a regular basis in the clinic and in research. And all of our research studies currently, our current NIH funded research studies require patients to be off of their meds 24 hours before the lean test. And I mean, it packs a wallop to most of the patients. It's just, it's pretty stunning. Yeah, it's pretty stunning.
Yeah, that would be a great if that could be, because the information that you get from that is double duty. You're getting the OI information and you're getting this component at the same time. So if you're going to require somebody to do something that's physically demanding, at least you're getting incredibly useful information from it, instead of it just being a 6-minute walk test for, what purpose is that?
You finished, Sally?
Yeah, sorry.
Oh, no, that's fine. I thought they were great questions. First thing I want to do, I don't want to, Lynn, I don't want to call you out if you don't feel comfortable, but we have someone with us. I believe she's from Sweden. And I just wanted to welcome you if you'd like to show yourself. And while she's deciding, Shad, my husband is an engineer, so he's always thinking of things, as far as MECFS as an objective measure. So I really appreciate it from the engineering side. And I do have some questions, but I wanted to, Lynn, would you like to say anything?
It's okay. I'm from Denmark, by the way.
Oh, Denmark. Okay, sorry. Welcome. We're glad to have you.
I'm listening.
My great grandparents are from Denmark.
Oh,
I had the pleasure about 2 years ago of visiting Aalborg, which is not far from where they're from.
Nice.
okay. Nice.
Nice to have you. So I just have some comments and a few questions. So I'm part of the subgroup of MECFS patients that in the past few years was diagnosed with hypermobile EDS and craniocervical instability and tethered cord. And so I had a cervical fusion a year and a half ago. And a lot of my comorbidities have improved, such as my POTS, whatever. And I do have tethered cord, but it's mild and it's not worsened since my surgery. A lot of people have to go in and have their cord released right after. But, and I've had it my whole life that I know now. I didn't know then. But I was just, a comment I thought about with, I know my upright activity is improved. But just, I don't know, this is just a comment for something that might show up in your subjects. Because of my tethered cord and because I'm short, my feet are rarely on the floor. I'm either standing, walking, I sit a little bit, but usually when I'm sitting, my legs are crossed in my lap. And I really believe that's due to the tethered cord. So my feet aren't actually ever really on the floor that much when I'm sitting. So that's just a thought that I was thinking about me, that if you notice that in your subjects, that might be something that's potentially playing a part in there. The other question I had was, I was really surprised when you had the numbers up that severe MECFS patients, their steps were above 5,000 and moderate was around 10,000. That was just really, from a clinical perspective and a patient perspective, that seems really high to me. I just wondered if there was a specific criteria you used to put them in severe and moderate, because a lot of, I guess the terms get used differently a lot, because a severe ME patient is primarily bed bound historically with that term. So the step count was, I was surprised at the high number of steps.
Yeah, that's a good observation. Well, so first of all, we didn't use steps to classify them as moderate, severe, or control, right? They were classified as moderate, severe, and control based upon their history with the Bateman Horn Center and also their self-reported Hua historically, hours of upright activity. So that's how the group classification came. Then we just took the data from the IMUs and calculated the steps per day and said, what does this look like for the different groups? Is it very different? You're right that number seems really high, and it's clearly different. I pulled the slide. Actually, I'll just share it. I pulled the slide back up. The number's really high. Now, and you make me realize I need to go back and look at this. It may be the case that this is we're getting a double count here because we have two IMUs. And we're calculating it from one versus the other. And I don't know whether we're adding those two together. I got to go back and look. So it's possible that those numbers there are we're double counting. But I need to go back and look at that.
That was an excellent observation, Melinda.
Yeah. That's actually, I'm glad that graph's not in the paper we published.
Well, just from my own personal experience, I've never been able to walk 10,000 steps a day. And I have always considered myself by most definitions moderate. And a lot of people who classify themselves as severe are under 1,000 steps for sure. Some are around maybe 500. So that was just, thank you for clarifying that. But if it did double itself, that would make more sense.
Yeah, that's the most obvious explanation I can think of. But I definitely want to go back and look at the details of those numbers now.
And the other comment that I had, just again, from a patient and a clinical perspective, based on some of the other science that we use, when you were talking about the higher heart rate in the more severe patient, the more MECF patients, MECFS patients, we use techniques and stuff from other scientific foundations too, and we've learned from them that anything like whatever your resting heart rate is, if you're having a flare, a lot of times your resting heart rate is going to be 10 beats or more higher, or it can be 10 beats lower in that area. So to me, when you were talking about the severe patients with the higher heart rate and just curious of the causes, I think that actually makes sense, that the heart rate would be higher.
And the other thing that's kind of tricky about the heart rate and the heart rate variability data is that it is from the Oura Ring, and the Oura Ring is only taking the heart data during the night for a 4-hour period or something like that. It's a relatively short period of time.
Yeah, as a general comment about the Oura Ring, that is one of the difficulties is it can measure a ton of data, but it can't store all that data, right? It doesn't have all the memory on board to store it. So, so it runs these algorithms to give you kind of higher level parameters, because
but you're right too, Melinda, that's what we see clinically.
Right. Well, I just, again, as Sally mentioned, our therapist, because of how we're trained, we're always looking for objective tools, and insurance reimbursement and all that is requiring it. So I'm really excited about this, and I look forward to following it, and hopefully we'll have another tool that we can introduce to our therapists that they can use to get some objective measurements with their patients, because truly hours of upright activity, or uptime as you call it, is it's one of the biggest obstacles that patients face, especially the ability to work. So I know a lot of patients have really thrived during the pandemic because they've been allowed to work from home. And like me, I can stretch out here on my, on my bed and talk to you guys and not have to deal with being vertical all day. So I think this is going to be a really, really important study when you're finished. And I just wanted to ask one more question. We had another article of yours listed, Dr. Vernon, the clinical assessment tools for documenting the impact of orthostatic intolerance on symptoms and function in MECFS. And in that article, you mentioned the orthostatic intolerance questionnaire that you designed. Is that something that's available to us as clinicians?
Yeah, so that's a standardized questionnaire that we did not design. What we did was, and the two graphs that I showed you are the kind of the components of that, the
Right.
OIQ, and it is available. I can send you a link to it
Okay.
afterwards.
Okay. Thank you.
You're welcome.
Yeah, this was great. Thank you so much. So much information, so much hope for what you guys are doing for the future too.
Yes.
Thank you so much for having us, guys.
Yeah, thank you. Really appreciate it.
Yeah,
Lynn, do
and
you have any questions?
I find it quite useful that you distinguish this foot on the ground or not, because my son at home is quite severe, but
Mhm.
because he have a balance chair he's sitting in most of the day, he's sitting up, but he's sitting with his legs high all the time. So no, he's not sitting up. So yeah, I'm excited about this new definition with feet down or not, legs not raised.
Right.
That gives a good meaning for me
Yes.
and a new way to see it.
yeah,
Think about that cone, a cone below the knee. That
Yeah.
that's a very, very useful way to kind of think about upright,
Yes.
not
Yes.
upright. Yeah.
Gives such a good meaning. Do you know what influence that have on the blood flow in the brain? Just asking.
Again, the only thing, no, not exactly, not directly. Anecdotally, yes. We think that when the feet are within that 39-degree angle, you are inducing some orthostatic intolerance. And so you have less perfusion to the brain. And then once you elevate outside of that 39-degree angle, 40-degree angle, you are allowing the blood to flow better to the brain.
When you're standing on a tilt table, will you be outside the 39 degrees?
That's a good point. So you know what a tilt table is, Shad?
Yeah.
Yeah.
So I imagine once you get,
You're standing pretty much tilted.
I think it's 70. It's a 70-degree. Most of them are 70-degree.
Yeah.
Well, yeah. So we measure 39. So that would be an equivalent to 20 degrees the way that we're measuring it.
Yeah.
So that would still be, 70 degrees, meaning that would be 90 degrees, and 70 degrees would be something like this, right? Yeah.
Yeah. Okay.
All I know is the worst test I ever had in my life.
Yeah, I don't think I could ever do it.
Yeah. Well, thank you so much. And we will keep following your work. And, like I told you, live attendance varies, but we do have pretty good follow-up with people watching the recording.
yeah. Thank you Yeah, and if there's ever anything you guys, especially from Bateman Horn, that feels really directly specific to rehab therapists, please just let us know and we'll disseminate it, through the group. We pay attention greatly to what you guys are doing and usually post everything anyway. So I doubt we're missing much, but you might have other things that you know of.
Okay, great, will do.
I just had a thought. It's been a long time ago. I read about, if you don't mind, let me stop the recording.